combining atom together. That is called as the chemical bond. And the reasons for the chemical bonding. First reason, there are two reasons. First reason is the tendency of the atoms to achieve the octet so that it becomes stable. The second reason is atoms combine to become stable while losing the energy. So that is the two reasons for the chemical bonding. Then in this chapter, various approaches we have to study. That is Coulson-Lewis approach, valence shell electron pair repulsion theory. That is VSEPR theory. Next is VBT, valence bond theory, and MOT, molecular orbital theory. So we will be studying one by one. Next we have, first is the ionic bond. We have studied ionic bond, or it is also called as electrovalent bond. Ionic bond is the electrostatic attraction between the positive ions and the negative ions. That is called as ionic bond. Two examples we have seen, that is sodium chloride and calcium fluoride. Two examples we have seen. Next is the Coulson-Lewis approach. We have started Coulson-Lewis approach. Their theory is called as electronic theory of the chemical bonding. In that, octet rule we have studied. Octet rule is very important. Octet rule statement: atoms can combine either by the transfer of valence electrons between the combining atoms or by sharing of the valence electrons in order to have an octet in their valence shell. I will repeat. Octet rule is, it states that atoms can combine either by the transfer of valence electrons between the combining atoms or by sharing of the valence electrons in order to have the octet in their valence shell. Later, scientist Lanier, he improved the Lewis approach and given the term covalent bond. And given the term, introduce the term covalent bond. Covalent bond is, it is a bond formed by the mutual sharing of electrons between the combining atoms of the same or the different element. Covalent bond is the bond formed between the combining atoms. It is by the mutual sharing of the electrons. These atoms it can be of same element or it can be of the different element. Then we have studied Lewis symbols. Lewis symbols. Lewis symbols means here valence electrons are represented in the dots. See, in your lower classes, for example, for the carbon I will show, the valence electron is 4. So 4 dots around the carbon atoms. In your lower classes, some of you might have studied the valence electron are represented in the combining atoms. So we have seen the example of chlorine, right? Chlorine, electronic configuration, neon, 3s2, 3p5. So total it is having 7 valence electrons, 7 outermost shell electrons. So for the chlorine molecule, now it is short of, chlorine is short of 1 electron, right? 3s2 3p5 is there. It is short of 1 electron to complete the configuration of the nearest noble gas, that is argon. For the chlorine, you see the bond formation. First we have to write the Lewis symbol of each chlorine atom. There are 7 valence electrons. Okay. So bond forms like this. Each chlorine atom shares 1 electrons. Like this. Okay. The single bond is formed here. So this representation, the other way also you can write. So I write it here. Cl. First 7 valence electrons. Sharing a pair of electrons like this. Each chlorine atom is contributing 1 electron to the bond. Now count the number of electrons in each chlorine atom. So first this chlorine atom, 1, 2, 3, 4, 5, 6, 7 and 8. So octet is completed here. Second chlorine atom also same, 1, 2, 3, 4, 5, 6, 7 and 8. So octet is completed even in the second chlorine atom also. So this structure is called as the Lewis dot structure. Lewis dot structure. Okay. So this is single covalent bond because a pair of electron is shared between the combining atoms. Next, 2 more example is given. So this chlorine example, 2 combining atoms are of same element. The other example, one more, that is water molecule. So here combining atoms are of different element. You see the structure. Oxygen in the center, hydrogen at the terminal position. First write the valence electron. Hydrogen is having only 1 electron. It is 1s1 electronic configuration. Oxygen, it is having 6 valence electrons. So I will write it like this. 6 valence electrons. Okay. Now there is a sharing, a pair of electron between hydrogen and the oxygen, or I can say oxygen atom will share pair of electron with each hydrogen atom. And this is for the hydrogen. For the oxygen, it is like this. Okay. So now hydrogen, there are 2 electrons after sharing. So duplet is completed in the hydrogen and it becomes stable by attaining the electronic configuration of the helium. this is the Lewis dot structure of the water. You can write it in the other way. I will write it here. First write the valence electrons. Sharing a pair of electrons, right? So single bond is formed. Okay. So this is the another way of writing the Lewis dot structure. In the exam, any one way you can write it. Which is easy for you, you can follow that one. Okay. So this is the water molecule. Next example for the single covalent bond. Carbon tetrachloride. Carbon tetrachloride. Formula carbon C. Tetra means there are 4 chloride. So Cl4. Carbon tetrachloride. Write the structure. While writing the structure here, now it is polyatomic molecule. Least electronegative atom occupies the center position. Like this. So keeping in mind, least electronegative atom occupies central position. Between chlorine and the carbon is the least electronegative. So this is written in the center. Now write the Lewis symbols, that is giving the valence electrons. Chlorine is having 7 valence electrons, 3s2, 3p5. Okay. Next for the carbon, 2s2, 2p2 valence shell. So it is having 4 valence electron for the carbon. Now if you look at the valence shell, there are 7 in the chlorine atom. It requires 1 electron. Whereas carbon, it is requiring 4 electrons. So there is a sharing, a pair of electron between the carbon and each chlorine atom, sharing a pair of electrons. So for the first chlorine atom, like this, carbon is sharing 1 electron, chlorine is sharing 1 electron, a pair of electron is shared. Then second chlorine atom, like this structure. Okay, this is for the second chlorine atom. Next, the third chlorine atom, like this. Now for the fourth, the last chlorine atom, like this structure. Now count the electrons of the chlorine atom. 1, 2, 3, 4, 5, 6, 7 and 8. So each chlorine atom octet is at 8. Carbon also, for the carbon is like this. Like this for the carbon. So look at the carbon. 1, 2, 3, 4, 5, 6, 7 and 8. So carbon also octet is completed. Okay. This representation in one more way I will show here, showing the bond. sharing a pair of electrons between carbon and each chlorine atom. So here it is having 4 single covalent bonds. Okay, so this is regarding the single covalent bond. In some of the compounds, single covalent bond will not satisfy the octet. So in such molecules, multiple bonds forms. Multiple bonds forms. It is having 2 multiple bonds, double covalent bond and triple covalent bond. First we'll see double covalent bond, or simply called as double bond. Double covalent bond means sharing 2 pairs of electrons. Sharing 2 pairs of electrons. Okay. Example is carbon dioxide molecule. 2 examples are there. First one is carbon dioxide molecule. So while writing the structure, least electronegative atom occupies the central position. So here carbon is the least electronegative atom, central, oxygen at the terminal position. Now represent the valence electrons. Carbon 4, 2s2, 2p2 valence shell. Oxygen is 6, 2s2, 2p4 valence shell. So it is having 6 valence shell electrons. Okay. So first we have to go for single bond. So go for the single bond, which the carbon and each oxygen atom. Now see whether octet is completed or not. We count for oxygen 1, 2, 3, 4, 5, 6 and 7. Similarly the second oxygen atom also, it is having the 7 electrons. Octet is not completed. Go for the double bond, sharing 1 more pair of electron. Okay, sharing 1 more pair. Now count 1, 2, 3, 4, 5, 6, 7 and 8. So octet is completed in the oxygen atoms. Just see the carbon 1, 2, 3, 4, 5, 6, 7, 8. So here also octet is completed. So this one more representation the other way. Sharing 2 pairs of electrons, right? Like this for the oxygen atoms. For the carbon, it will be like this circle. So that is for the carbon. Octet is completed. This is the Lewis-Dot structure of the carbon dioxide. So next is ethene molecule. Okay, next example for the double covalent bond is ethene molecule C2H4. First write structure. So carbon, the center, hydrogen at the terminal position, writing the valence electrons. Hydrogen is having 1 valence electron. Carbon, each carbon is having 4. So 4 valence electrons. Okay. So first hydrogen, there is sharing a pair of electron between the carbon and hydrogen. Sharing a pair of electrons. So what happens? Hydrogen duplet is completed. Now look at the carbon, each carbon. So now this carbon is having 1, 2, 3, 4, 5 and 6 electrons. Similarly with the second carbon atom also. Each carbon requires 2 more electrons. Now between the carbon, first sharing a pair of electrons. Okay, sharing a pair of electrons. Now each carbon is having 7 valence electrons. Sharing another pair of electron will complete the octet. Now you can count. First carbon 1, 2, 3, 4, 5, 6, 7 and 8. So each carbon has completed the octet. Between the carbon atoms, double bond is formed. 2 pairs of electron is shared. Between the carbon and the hydrogen, it is single covalent bond because of sharing a pair of electrons. This structure, the other way I will present. Carbon, four valence electrons of the carbon, hydrogen 1. So this hydrogen sharing a pair of electrons, okay, like this. Now for this carbon, structure is like this. Okay. Now for this carbon, this like this. Between the carbons, 2 pair of electron is shared. So it is called as double covalent bond. Next is triple covalent bond. It is one more multiple bond. Triple covalent bond means sharing 3 pairs of electrons. Sharing 3 pairs of electrons. Example. Here also 2 examples given. First one is nitrogen molecule, N2 nitrogen molecule. First write the Lewis symbol of the nitrogen. Nitrogen is having 5 valence shell electronic configuration, outermost shell, that is 2s2, 2p3. So 5. First we'll go for the single bond, that is sharing a pair of electron between the 2 nitrogen atoms. If you count the number of valence electrons now, each is having 6 valence electrons. See, 1, 2, 3, 4, 5 and 6. So octet is not completed. You have to go for double bond, sharing another pair of electron. Now it is having 7. 1, is not completed. Each nitrogen requires one electron each. So sharing one more pair of electron between the nitrogen atoms. Now count 1, 2, 3, 4, 5, 6, 7 and 8. So octet is completed in each nitrogen atoms by sharing 3 pairs of electrons. So it is called as triple covalent bond. Okay. The representation, one more way I will write. Sharing 3 pairs, right, like this. Okay. So this is the latest dot structure of the nitrogen molecule, showing triple covalent bond or simply triple bond. So here, try to heading non-bonded electrons, or it is also called as lone pair of electron. Lone pair of electron. One more is bonded electrons. Bonded electrons or shared pair of electrons. Non-bonded electrons, as the name suggests, it is not taking part in the bond formation. It is free. It is not taking part in the bond formation. Or it is called lone pair of electrons. Bonded electrons means which is taking part in the chemical bond formation. So it is called shared pair of electrons. Now look at this nitrogen. In the nitrogen, there is one lone pair of electron. Two non-bonded electron. 2 means it forms the one pair. So there is one lone pair of electrons. So it is having one lone pair of electrons and 3 shared pair of electrons. There are 3 bonds here. So 3 shared pair of electrons. Or you can say 6 bonded electrons. 6 bonded electrons or 3 shared pair of electrons, 2 non-bonded electrons or 1 lone pair of electrons. Next is one more example for the triple covalent bond, that is ethyl. Ethyl, or it is also called acetylene. Acetylene, formula C2H2. Write the structure: carbon, 2 carbon in the center, 2 hydrogen atom at the terminal position, represent the valence shell electrons. Hydrogen is having 1 valence shell electron, 1 outermost shell electron. Carbon is having 4, 2s2, 2p2, right? Each carbon 4 valence electrons or valence shell electrons. So first, with the hydrogen atoms, each carbon shares a pair of electrons with the hydrogen atoms respectively. Means duplet is completed in the hydrogen atom It attains the electronic configuration of the helium, noble gas, so it becomes stable. Now between the carbons, between two carbon, first sharing a pair, one pair of electron. Count 1, 2, 3, 4, 5 and 6. Each carbon, it is 6 electrons will be present. Octet is not completed. Then go for sharing another pair of electrons. Now each carbon will be having 7 valence electrons, which is short of 1 electron to attain the octet. So go for sharing another pair, one more pair of the electrons between the carbon. Now count carbon 1, 2, 3, 4, 5, 6, 7 and 8. So each carbon atom between them sharing a 3 pairs of electron, and with the hydrogen sharing a pair of electron completes the octet in the carbon. Okay, so another way to manage. For the hydrogen, like this. For the carbon, it's like this. Okay. Between the carbon, triple covalent bond. Between the carbon and the hydrogen, single covalent bond. In the carbon, there is no lone pair of electrons. Okay, so all shared pair of electrons or bonded electrons are present. Next is Lewis representation of some of the molecule or ion we have to state. Lewis representation. Since covalent bond, it will be asked for 2 marks for the exam, like single covalent bond and give an example, or double covalent bond, give an example. That time we have to write the definition first for the single covalent bond and an example. It can be water or chlorine molecule, okay, or carbon tetrachloride. Any one example you have to give. Next, Lewis representation of some of the molecule and ion. First one is hydrogen, H2. H2, here combining the atoms are of same element. So hydrogen is very simple Lewis representation. also sharing two pairs of electron between the two oxygen atoms. It forms the double bond. So these structures are simple. Complex molecules, there are three steps we have to follow. Okay, steps for the Lewis representation. First one, step 1 is count the valence shell electrons. Count the valence shell electrons. Second step, okay, here in step 1, when counting the valence shell electrons, for example, carbon monoxide. Here carbon valence shell electron is 4, oxygen 6. So it is having 10 valence shell electrons. Ion, if you take NO2 minus. So here nitrogen is having 5 valence shell electrons. Oxygen is 6. There are 2 oxygen atoms. So 2 into 6 plus, since there is a minus sign, means it is an anion. Anion means electron is gained. So plus 1. Since there is only 1 minus charge, plus 1 we have to write. So keep this in mind when calculating the valence shell electrons for the anions. The charge also you need to add. If it is positive ion or cation, you have to subtract that. Okay. So here now it is having 16 to 12, 12 plus 5, 17 and 18 valence shell electrons. So that is the first step. Second step, writing the skeletal structure. Writing the skeletal structure. While writing the skeletal structure, you have to keep in mind least electronegative atom. Least electronegative atom occupies central position. Least electronegative atom occupies central position. Then step 3. After writing the skeletal structure, for example, I will write here NO2 minus. NO2 minus. In the NO2 minus, N is nitrogen atom. It is least electronegative. Oxygen is more electronegative compared to nitrogen. So nitrogen is, since it is least electronegative, it occupies the central position. Oxygen at the terminal position. Since it is an anion, bracket you have to put and minus charge outside the bracket. Now this is the skeletal structure of the nitrite ion. This is called as nitrite ion. Okay. Next step 3. Step 3 is result in the sharing the pair of electron. First sharing a pair of electron. If octet is not completed, then resort to multiple bonding. That is double bond or then if octet is not completed in any one of the atoms, then you have to go for the multiple bonding. Okay, we continue in next class. Thank you.